We have discussed the phase changes and state of matter in previous podcast. Here we will discuss what happens when a material changes state. Solids, liquids and gases exist as an equilibrium between two factors, the bond forces pulling the particles within a material together, and the movement of the particle from heat energy, shaking them apart. If the material doesn't shake too much, the heat energy per particle is low and the temperature is low. The forces pulling particles together compared to the shaking of the heat pushing them apart is very high. The particles can be held together rigidly until they form a lattice structure where each particle in the material is pulled equally by each other particle in the material. If the process of turning solid is completed over a long period of time in a pure material, you would have one single crystal lattice throughout the whole material. All the particles will be held together by 6 other equal strength forces from 6 different directions. The particles could be said to be held together in a solid lattice. Now you raise the temperature of these particles by adding more heat energy. The particles closest to the heat source vibrate more initially and bounce into other particles near to them in the solid lattice until the heat from the source has been transmitted throughout the entire material. This is how thermal conduction works. If the heat is kept on the material, the particles will start to vibrate more and more because each particle is receiving more heat energy for itself. The average heat energy per particle increases, and therefore so does the temperature of the whole material. At a particular point, the vibration of the particles within the material is strong enough to overcome the collective bond strength of the material. Chunks of material now behave like individual particles and move around together. This is the difference between a solid lattice and a liquid collection of lumps of particles. At this point, the particles within the clumps all vibrate at the same frequency. It is the clumps themselves that start to move around and use up energy. The heat energy that is supplied to the material now goes into forming more clumps of particles that can also move around freely. As the particles within these clumps do not vibrate faster or slower, the average heat energy per particle remains the same, and so does the temperature. The heat energy supplied continues to increase until all the particles within the solid lattice have been broken up into clumps, which are floating freely around each other. At this point, the heat energy supplied to the material goes to further vibrating the individual particles within these clumps. The total energy needed to turn the material from a solid lattice to a liquid collection is called a latent heat. In particular, the transition from solid to liquid is called the latent heat of fusion, as it is the same amount of energy that is taken away from a liquid to make it solid again. This is different to the energy needed to separate all the particles within the lumps into individual particles all by themselves. This is called the latent heat of vaporization and is needed to turn a liquid into a gas. The energy required to change state is therefore given as the mass of a material to be changed times by the latent heat. Latent heat is given the symbol of L, a lowercase l, with either a subscript F or V, depending on whether it is on fusion or vaporization. Fusion being changing from solid to a liquid or liquid to a solid, and vaporization from liquid to a gas or gas to a liquid. The only factor here is the mass of material you have to apply your heat energy to. Obviously, the more massive a material, the more particles there are, and so the more bonds that need to be broken to change state. Specific materials have specific bond strengths between their particles, and so have different latent heats for different materials.